Welcome to my channel in tutorial in KISSsys gear design. So today we will have the continuation of our tutorial in the two stage industrial gearbox. So in our part 1 and part 2 we learned how to model this KISSsys and KISSsys components and uh, define the gear and have fine sizing. So for today's tutorial will be focused in shafting and then bearing calculation of the assembly. So okay, let's start our tutorial. And another one, I have this PME code here. So in the Philippines we use this code in shafting, for shafting. Okay, in our KISSsys model, make sure you unlock the admin button to use the KISSsys system. So we have 3 shafts here, shaft 1, shaft 2 and shaft 3. So we need to design this part one by one. So double click the shaft 1 calculation. So this is now our model, and we have to input this data for the length of the shaft. So okay, first thing to do is to check the basic data for the speed. So we have 194 RPM by using our PME code set to input here 194. So this is a main shaft. So the resulting diameter is 49.55 mm. So let's say 50 mm. Then let's go back to our shaft editor tab. Then we have two ways to input or to model our shaft. We can use the tab at the right side, or we can use our elements list. So for this tutorial for shaft 1, I will use the elements list. Then later for another shaft, for the shaft 2, we can use the tab. Okay, for the element list, we have just to count how many sections the shaft have. So 1, 2, 3, 4. We have 4 sections. So from the elements list, you can right click at this area, then add cylinder. So meaning we need to add 4 cylinder here. Okay, then adjust the length at this portion. So our first length is 90, second is 50, third is 400, and for the last is 21. Then for the diameter of the shaft, we computed that the minimum should be 50. So from this drawings, then our minimum shaft here is the bearing shaft, bearing feature, and for the coupling section, so let's say 50, say 60 for this one, add 10, 70 for the stopper. So we have now our shaft. So this is the method in using the elements list. The next is we need to arrange the components inside. So right now it is locked. So to unlock the components, you have to right click at this window, then check the movable forces and supports. So again, let's check. So now it is already checked. So the items or the components now can be moved. So you have to arrange this in its right position. So for bearing 2, it should be at this part. Bearing 1, the coupling and the gear. Okay, we remodel the coupling. Let's say the diameter is 100. Then I will adjust the length, same of the shaft. Then for the bearing, guys, the software has already the standards bearing here. So we just need to select the size and let the KISSsys compute the solution if it is acceptable or not. So how to do this? We have to check the type. So let's say I will use deep groove ball bearing because this is just only a spar gear. So as you can observe, the gear automatically updated for the standard size, specifically in the diameter of the shaft. The next is we need to choose the standard. Let's say I will select KISSsys 6012, then right click, make contact to the left. So the bearing now is in touch with the edge. Then let's say bearing 2, same deep groove ball bearing. Let's see, I will use this one, 6010. Then again, contact to the left. Then we can adjust later the size. It depends on the size of our bearing selected by the KISSsys. So for the gear, let's say 250 for the distance from this 0 position. Then click run. So we have here a warning: the required service life is not achieved. So meaning it is less than our standard. So when we check the B1 or the bearing 1 life is 3695. So let's first adjust the standard. So let's say 5,000 hours because we use this in agricultural application. So this is below our expectation life, so we'll need to adjust again. Just click the bearing, then select the next higher size. Then again, let's contact to the left. The other one, guys, is we need to adjust the type of bearing. So let's say this is a fixed bearing adjusted on the left side, and this one is also a fixed bearing adjusted in the right side. Then click run. So okay, now the result is here. The life of our bearing 1 now is 21,000. So this is times 4 or required life of 5,000, and this one is 41,000 for the life. So this is acceptable now. Our bearings are acceptable. Then let's now check for the deflection of the shaft. So here our maximum deflection is 105 microns. So let's check in the model. So from this tab, let's check graphics, select shaft, then select displacement bending. Then let's put this in the side. So our bending here is 105 microns, so almost 100.1 mm. So guys, if this is acceptable to you, this is okay, but for me, we can check this one with the 3D model, 3D deformation. So I think this is not acceptable because, as you can see here, we have a big deflection from our reference. So we can adjust this one. This is just our rough sizing, so we need to adjust the diameter from 60, let's say 75. Then run again. So from 100, it's now 43 microns. So let's make it smaller, so let's say 85. Then run again. So we have now 30 microns. I think this is acceptable, but we need to adjust also the shafting. So from 85, let's say for the bearing, this is 75. For this one, this is 95. For the stopper, this one is 75. So we'll try also to adjust our bearing for the available standard. Contact to the left, then again find the, let's say 6017, then let's run. Let's see what will happen. So here our maximum deflection now is 32 micron. So the deflection also adjusted because of the bearing capacity. That's why it's now 33 microns. So we can adjust again if we, for example, we need to select another bearing. Let's see the result. Let's run. So minimal. So again, this just back to 60-17 because the bigger the bearing, of course the cost increases exponentially also. So okay, this is now our result. So we have the bending, let's see with the 3D compared to our previous model. So I think this is acceptable. Okay, then let's close this one and update our assembly. Okay, so this is now our shaft 1. Then let's now proceed to shaft 2 for the upsizing of the shaft. So for idler shaft, we will use this dimension for the length. Then let's go to basic data. So here our speed is 39.5 rpm. So using this is an idler shaft, so we can use this line shaft. Then let's input the data from SME code. So our minimum diameter here is 73. So let's say 75. Can use 75 here. Then let's simulate again. Then check how many features we have. 1, 2, 3, 4, 5. So we have section, 5 section. So again, by using the tabs here, so in the first shaft we use the elements list, but for this second tutorial we use the tab. So left click this 1, 2, 3, 4, 5. So we have 5 shafts now. Then we have to edit individually. So for shaft 1, the length is 30. Then the diameter, in our computed diameter, the minimum is 73. Let's say 75. Then for shaft 2, the length is 150. Let's say the diameter here is 85. For shaft 3, the length is 75. Then the diameter, let's say 95, is much higher. Then the other one, the length is 125. This is also for the gear. And let's say 85. Then the last length is 30. Diameter is 75. So okay, we have now our shaft rough sizing. So we use the KISSsys to optimize the shaft later. Then again, right click, then check the movable forces so we can adjust the gear. So we will move the gear here. Okay, for the stopper. Then also this one. Okay, then for the bearing, we have 2 bearings. Then again, deep groove ball bearing sizing, let's say we use first the 60-15 contact to the right. This one also deep groove ball bearing, let's say 60-15. Then let's simulate. So the required service life of bearing is not achieved. Same with the static factor of safety. So you can observe here a very minimal size of the bearing. Then the maximum deflection of our shaft is also big, 78. So we can adjust this one. Let's say 100. So this one will increase also 110, 100. Then let's say 90. Then let's try to generate another bearing. Another bearing. You can generate this one. Then let's try again. So the life of bearing 1 is still not met for 5. So next size, we have to select the 6218, contact to the right, then run again. So you need to adjust the settings here. 5,000 hours. So okay, when we check this one, the diameter now have 52 microns deflection. So our bearing is okay. We have 20,000 and 13,000 life, so this is acceptable already. But for this size of the shaft, you need to adjust this one. So let's say 140. This is say 150, then 140, then 120, then let's change again the bearing. Deep groove ball bearing, then 6024, and this is adjusted and fixed on the right, adjusted on the right side. Then this one adjusted in the left. Then let's run. Okay, we have 13,000 hours, 44,000 hours for the bearing 4, then deflection of 26. So this is acceptable. It's less than 30 microns. So we can adjust this one, let's say to 80, to 80. Okay. Then this one 135 is okay. So we can run. So this is now our updated shaft 2. Let's close and let's click update. So as you can observe here, our software updated automatically. Okay. So as you can observe, we have the bearing here, then the bearing here. So we need to reposition the shafting and the bearing so that it will match with our shafting here in this position. Okay, shaft 2. Just need to rearrange the bearing. So let's say this one is 140, 150, then this one is to, let's say 300. Okay, then run, close. So this is now the position. Let's arrange for shaft 1. So I think the position here is you need to adjust. Say this is 300. So it's much better. Okay, then run. So we have no error, but we have error in the B6 other bearing because we still not size this one. Okay, the next, let's proceed to shaft 3. So for our driven shaft, let's now proceed to driven shaft. We have how many feature? 1, 2, 3, 4. So we add 4 feature here. 2, 3, 4. Then we have to input the length. Let's say 35. Let's say 345. Let's say, sorry, for the length. For the diameter here, we have to compute later. Okay, for shaft feature 2 length is 345. Feature 3 is 150. Then the feature 4 length is 50. Then again, let's check the basic data. It is 10 rpm, so this is for main transmitting shaft. So we have 133, so let's say 140 for the minimum diameter to shaft editor. So this is 140, this is 140. The next is for the shaft, let's say 150. And this also 150. So let's increase the size, 160. Okay, so this is now our shaft 2, shaft 3, sorry. Then movable forces, let's check, and let's put the bearing and the coupling here. So this is now our system. So this is, I think, a bearing here and coupling here. So we will adjust the bearing now. Bearing 1, so deep groove ball bearing, then select size, then fix bearing on the left side, then contact to the right. Same with this bearing, deep groove ball bearing, then contact to the left. Then for locating, adjustable on the right side. Then this, we have to adjust the diameter of our, let's say 150 for the diameter of the coupling. Let's make it 200. Within the width, let's say 50 also. That's it. Then for the position of the gear, we will adjust later based on our assembly. So let's say 250. Then run. So okay, our life here is 79 for the gear, for the bearing, and 29 for the bearing 6. Then our deflection is 24 microns. So I think this is acceptable. So this is our bearing and run. So with the 24 microns deflection, this is okay. So just run, close, and run the assembly. So this is now our design, so we can rearrange the position of the gear. So let's say 200. the other side. So let's say 150. So it's on the other side, 300. Sorry, 300. So 23. So our bearing life here is less than 100,000 for the bearing 5. So close, then update. Okay, so I think this is much better with the alignment of the bearing for our housing. Okay, then let's run. Okay, so this is now our 3D model for the assembly. Then we can add the table here. So we can add table for our bearing calculation. Just copy, right click, copy this one, then paste to our model for the bearing calculation template. Then for the gear pair calculation, copy again, then go to the model, then paste, then the 3D, copy, then model, then paste, then run again. So here we can now check for our bearing calculation. So this is our bearing. You can export this to Excel file. So this is our bearing, the sizes for the gear pair calculation. Okay, for the materials. Then for the 3D view, so we can run. This is now our 3D model. Okay, symmetric view, top view. So this is now our assembly. Then if you need to save this one to be used as a step file in your other 3D CAD model, just click this KISSsys 3D view, right click, then export geometry. So this can be saved as step file or IGs. So just input here, then just save. Okay, so that's it. I think this is the end of our tutorial for the two-stage gearbox design. So thank you, and again, please subscribe in my channel and like my videos.